All right, so here's 4.4. This is the transformation of functions, and I think this is what y'all were talking about. Is you wanted to help with was to know about this part right here. And this is an important question because as you'll see it again on the test, probably on the final. This is a good way of asking these types of questions. I know I give this question on my test all the time, so you got to make sure you understand what a horizontal shift is, the stretch or compress, the x-axis, y-axis reflections, and a vertical shift. And you do that by, well, there's a couple ways. You can either graph this on your graphing calculator and compare that to the basic function this is based off of. Now, the basic function this is based off of is x cubed. So when you're looking at what you're basing this off of, you're looking at x cubed. Well, that is what's given over here. That's the basic function. Now, if you graph this on your graphing calculator, you'll just see a new graph, but you won't really understand what happened. So you have to understand what's going on here. The x plus 2 inside here is always going to be your horizontal shifting. If it's inside parentheses in this nature, it's going to be the horizontal shift. That's what the horizontal shift is. It's going to look like some type of grouping. So for instance, if it was this guy versus x plus 2, like they have here cubed, that's going to be, you would think that would be to the right 2, but it's actually to the left 2. It's sort of like those circles. You remember how this number was opposite what it said there. If you're basing it off of x squared, well, it'd be x plus 2 squared. That's how you get a left 2 shift. What about the absolute value symbols? Well, it would be x plus 2 in the absolute value symbols. That's going to get you left 2 units. That's how you're going to get the left 2 and so on and so forth. Let's try similar here. All these, if you notice, if you look up here, I'm going to click on try similar each time. Basically, this question is just asking about the horizontal shifting. That's all it's asking about. So that would be to the right 6. This would be to the left 6. Left 6. Right 6. Left 6. Can we get anything else here? Aha! To the right 2. Minus 2. Now what you do is you click on right, and you put 2 in, and it shifts that thing over. Let's see if we can find us another. Ah, look at this guy. A lot more to this one. Now, on this one, what's this based off of? That's the thing you have to ask yourself. Now, it's based now. Right here is the common functions. You'll see this on this formula list that we have. It's based on this, where it's the most common function. And there's our huckleberry right there, the square root of x. That's what it's based off of. Now, there's a picture of it on our screen here, right there. So if you put square root of x in your calculator and graph it, then you'll get that right there. Okay? Now, if you take a function and remember, if we want any horizontal shift in this one, there is none, because if you wanted the horizontal shift, you'd have to be underneath the radical. You'd have to say x minus 1, x plus 1, x plus 5 under the radical. You don't have any of that. What you have in this question is a negative x over 3 plus 5. The plus 5 is on the outside. That means it's going to be a vertical shift. It's going to be an up vertical shift of 5. Now, anytime you see a negative, you should think reflection. Anytime you see a negative thrown in here, you should think of a reflection. Anywhere in here, if there's a negative, think reflection. Now, if the negative is on the x, if that thing is right up next to the x, that's a y-axis reflection. This is a y-axis reflection. If that negative right here was on the outside, negative square root of x, that's an x-axis reflection. What we have is a y-axis reflection. So what we have is a y-axis reflection. We don't have an x-axis. There was no horizontal shifting. Now what about this divide by 3 business? Well, Hawks kind of gives a little bit away. If you click on stretch, you look on the factor over here, it's a whole number box. But if you click on compress, it's a fraction box. And this is definitely a fraction. 1 over 3 basically is what this is. You could rewrite this as 1/3. Square root of negative x plus 5. When you multiply by a fraction, you get a compression. I'll put 1/3 in here. 1/3. And you get the compression. It's a vertical compression, I do believe. You notice how it got scrunched vertically. And that's what you got. Oh, what did I not put in? Ah, horizontal shift. There is none. That's another thing on the test. You'll forget to pick one of those. So hopefully you don't do that on tests like I did. Way to go. Now you get domain and range. Well, if you click back here, you get to see what you had. So that's what I had. Well, remember here, this basic graph that you had before, it's well, you had this on your paper, and you already I think we wrote down what the domain and range of this thing is. The domain would be from 0 to infinity, and the range would be from 0 to infinity. Now, if what we've done here is reflected it and then moved it up 5. The only thing that got changed in the domain was the reflection in the y. You flipped it completely over the y-axis, so it doesn't use the positive x values anymore. It only uses the negative x values. And the reason why that is because you can put a negative in, and the negative in front of here would cancel the negatives, and you'd be left with positive answers to take the square root for. So your domain now would be from negative infinity. I guess I can just type it in. From negative infinity. Let's see if you like that now. Negative infinity to 0. We didn't do any left. There's no horizontal shifting in this. But now we did shift it up by 5. We took the original and shifted it up 5. So we're going from 5 up to infinity. We're going to use all the y values. Eventually, it doesn't look like it, but eventually this thing will curve and curve and curve and curve and curve and curve. It will use all the y-axis from 5 and up. From 5 and up. So you take your original and you just change that 0 to a 5 in the range. From the range of your original, you just change that to a 5. So I'm going to use a square bracket, 5, comma, infinity. See if I'm right. Takes a second or two. Sweet. I got it right. Okay, here's another one. So now you've got a +3 under the radical. If it's under the radical, it's going to be a horizontal shift. It's a +3. You think, oh, +3. Go over 3 this way. But that's wrong. It's actually to the left 3. Remember how that worked with the circles? It works the same way here. So you got to shift over. It shifted over 3 units to the left. There's no multiplying by a fraction. There's no multiplying by anything. So there is no compression. If you multiplied by 4, there'd be a 4 out here, and you'd say stretch. If you multiply by 4th or divided by 4th, if it was divided by 4, say like this, or negative 1/4 x plus 3, that would be a compression. If it was just a plain old 4 square root of x plus 3, that would be a stretch. But we don't have one here. X-axis reflection, yep, right there it is. That little negative right there. So yes. Y-axis reflection, well, there isn't a negative in front of x, so no. Vertical shift, well, you'd have to have something out here all by itself, and there's not. So you just clicked on none. Good going, me. Okay, now you get to find the domain range. Remember what the domain of this thing looked like to begin with. It's a square root. Square roots domains are from 0 to infinity, and the range is from 0 to infinity. Square brackets on the zeros. Well, now we took the domain, we messed with the domain now. We've shifted the domain back by 3, back to a negative 3. So the domain is going to be shifted back 3, and then it's going to go off to the positive x values. We're going to use all the positive x values, none of the negative x values. So from negative 3 to infinity would be the domain. Let me close this down here. -3 to the 4. And then the range, well, look what happens on the range. It was going upwards, right? It was from 0 to infinity. Well, you're not going up anymore on the y-axis. You're not using any of these up higher. It's never going to cross the x-axis here. It's always going to be in the bottom part of the y. You're going to use all these y values is what you're going to use. So from negative infinity all the way to 0. So since you reflected the x-axis, you basically reflected the range over. So we're going to go from, I'm sorry, wrong one. That guy, from negative infinity to 0. Now, if you don't know that, if you don't know how to reflect this, you're just looking on the graphing calculator, you're not going to know what those numbers are. You're not going to understand what's going on. You have to understand how these things shift up and down, left and right. So, hope that helps.